If you've ever played with magnets, you know there's a difference between them. There are those we use to stick things on our fridge, which are weaker, and there are also some stronger ones that have many other uses. But the secret to making strong magnets lies in one element. So today we're going to talk about neodymium magnets. Tell me more about the engineering. Today we're going to talk about one of the most fascinating materials in modern engineering, the neodymium magnet. Have you ever stopped to think about how a small magnet can be so powerful that it can lift objects much heavier than itself? Or how these magnets are able to maintain such an intense magnetic force even under extreme conditions? Well, the answer lies in a unique combination of chemical and physical properties that make neodymium an extraordinary material. But what exactly is a neodymium magnet? To understand this, we need to start with the basics. A neodymium magnet is not an ordinary magnet like the ones you put on your refrigerator. In fact, it is a metallic alloy composed mainly of neodymium, iron, and boron. This specific combination of elements creates a material that has extremely strong magnetic properties, far superior to traditional ferrite or alnico magnets. Neodymium is a chemical element that belongs to the group of lanthanides, also known as rare earths. But why exactly does this combination of elements generate such extreme magnetism? The answer lies in the atomic structure of neodymium. Do you know what makes a material magnetic? Well, it all starts with the electrons. Each electron has a property called spin, which can be imagined as a tiny rotation. When many electrons have their spins aligned in the same direction, they create a collective magnetic field. In neodymium specifically, the electrons in the 4f shell have a special characteristic. They can keep their spins aligned much more stably than in other materials. This means that neodymium has a natural ability to generate intense magnetism. But wait, if pure neodymium is already magnetic, why do we need to add iron and boron? The answer is that the Nd2Fe14b alloy, which is the chemical formula of the most common neodymium magnet, creates a special crystalline structure that greatly amplifies the magnetism. Iron contributes its own magnetic properties. Meanwhile, boron helps stabilize the crystalline structure, increasing the material's coercivity. If you don't know, coercivity is a technical term that means the material's resistance to losing its magnetization. In other words, the higher the coercivity, the harder it is to demagnetize the magnet. Now let's talk about the physical characteristics that make these magnets so special. One of the most important properties is the magnetic energy density, also called the maximum energy product. Neodymium magnets have a magnetic energy density that reaches up to 50 megagauss oersteds, which is about 10 times higher than traditional ferrite magnets. This means that in a much smaller volume, the neodymium magnet can generate a much more intense magnetic force. That's why you see such small neodymium magnets being able to lift heavy objects. But how exactly is this magnetic force generated? When you magnetize a material, you are aligning the microscopic magnetic domains inside it. Think of each domain as a tiny magnet. When all these tiny magnets point in the same direction, their magnetic fields add up, creating a much stronger magnetic field. In the neodymium magnet, the crystal structure of the neodymium iron-boron alloy allows these domains to align extremely efficiently and stay aligned for a long time. This is what makes the neodymium magnet permanent, meaning it keeps its magnetization without needing an external energy source. Another crucial physical characteristic is the Curie temperature. Do you know what happens when you heat a magnet? Well, as the temperature increases, the thermal energy starts to disrupt the alignment of the magnetic domains. There is a specific temperature, called the Curie temperature, at which the material completely loses its magnetization. For neodymium magnets, this temperature is approximately 310 degrees Celsius. This is relatively high compared to other magnets, which means that neodymium magnets can maintain their magnetic strength over a wide range, making them suitable for many industrial applications. But what is the secret behind this extreme magnetic strength? The answer lies in a property called saturation magnetization. This means that neodymium can reach a state of magnetization very close to its theoretical maximum. Combined with high coercivity, this results in a material that not only generates a very strong magnetic field, but also manages to maintain this field in a stable way. The tetragonal crystal structure of the neodymium, iron, and boron alloy creates a very strong magnetic anisotropy, which means that the material has a very pronounced preferred direction for its magnetization. This contributes to the coercivity and the stability of the magnetic field. Now you might be wondering, if neodymium is so powerful, why don't we use neodymium magnets in everything? Well, there are some limitations. First, neodymium is a brittle material and can break easily if subjected to mechanical impacts. Second, it is susceptible to corrosion, especially in humid environments, and that's why neodymium magnets are usually coated with nickel, copper, or gold to protect them. Third, the cost is higher than that of traditional magnets. And finally, at very high temperatures, close to the Curie temperature, the magnet starts to lose its magnetic strength. But despite these limitations, neodymium magnets have revolutionized countless applications. They are used in high-efficiency electric motors, wind power generators, computer hard drives, headphones, magnetic resonance imaging in hospitals, and even in aerospace technologies. The unique combination of chemical and physical properties of neodymium, iron, and boron has created a material that defies the limitations of conventional magnets. If today you use a tiny Bluetooth earphone in your ear with exceptional sound quality, it's because the audio drivers in the earphone could be made smaller with the use of neodymium magnets without losing quality. And you know, when we talk about innovation in materials like neodymium, we're talking about professionals who had a brilliant idea and managed to turn it into a product that billions of people use every day. So, did you have any idea how neodymium magnets can be so powerful? Have you ever stopped to think, how many of these magnets do you have at home, hidden inside your electronics? Leave it here in the comments, I want to know. Right here on the side, there are 2 interesting videos that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering enthusiasts. Big hugs, and I'll see you in the next video.